In this video, I'm going to teach you how to solve this question. So the first thing, write out your solution. And you write out the given DE, differential equation. The squared y over the t squared plus 4 dy over the t plus 3y equal to 2 arrow function of t. Let me make this. So now there are 3 steps to solve a differential equation using Laplace transform because that's what we are going to use. So the first step is find the Laplace transform of the DE. That's the differential equation. Then after that, you substitute. Second step, substitute initial conditions and make f of s subject of the formula. Now the third step is to find the inverse Laplace transform. The third step is to find the inverse Laplace transform of f of s. Inverse Laplace transform of f of s. So let's start with step 1. We can rewrite that equation as y prime prime of t plus 4 y prime of t plus 3y equal to 2 arrow function of t, arrow of t. So y prime prime of t is the same thing as the squared y over the t squared. Y prime of t is the same thing as the y over the t. So we can continue. Applying the first step, Laplace transform of this dE plus 4 Laplace transform of this, and then plus 3 Laplace transform of Laplace transform of this is equal to, from what we're given, we know that rho of t is equal to 1. So we can substitute it, which will give us Laplace transform of 1. Now Laplace transform of a differential, let's say y of n t is equal to Sn f of s minus Sn minus 1 Sn minus 1 f of 0 minus Sn minus 2 f prime 0 keeps increasing like that. It keeps increasing like that till f n minus 1 of 0. So we can apply this. If I apply this here, we are going to get, we are going to get s squared y of s minus s y of 0 y prime of 0 plus 4 Laplace transform of y prime of t is s y of s minus y of 0. From here you can see that I used f of s, f of 0, f prime of 0. It's still the same thing as saying y. It's still the same thing. So you can still use y in place of it. Then plus 3y of s is equal to Laplace transform of 1 is 1 over s. So this is what you have, 2 over s. So now, second step after getting the Laplace transform is to substitute initial condition. So substitute initial condition and make f of s subject of the formula. So now substitute initial condition and make f of s subject. So now substituting initial condition, if you could remember, the initial condition was y of 0 is equal to 1 and y prime of 0 is also equal to 0. So we can substitute y of 0 is 1. So we can substitute it as this will be s times 1 is still s plus 4s y of s, because this y prime of 0 is equal to 0, so I just removed it, and expanding the second bracket, this is what you have, minus 1 2 times 4, that's minus 4, plus 3y of s is equal to 2 over s. So you can see that f of s is still equal to y of s, so we can make it subject from here. Factorizing, you can collect like terms and factorize. You have this s squared plus 4s plus 3 is equal to 2 over s minus, sorry, plus s, moving s to this other side since it's not, it doesn't have y of s, and then plus 4 2 plus 4. So now y of s, if we make it subject, this will be equal to, let me do it step by step, plus 4s plus 3. This will now be equal to, if we add the right hand side, you have that the LCM is s, so this will be 2 plus s squared plus 4s, and y of s is equal to 2, dividing both sides by s squared plus 4s plus 3 gives you this, in order to make y of s subject, s squared plus 4s plus 3. So now that we have done this, we need to find the inverse Laplace transform of y of s. But before we do that, we need to convert this y of s to partial fraction. We need to get the Laplace transform using partial fraction method. That's the only way we can actually achieve this. But I will not do that here because I already explained that in my previous video, so you can go and watch it and learn from there. I'll just go straight to the point so that this video will not be too long. I'll just give you what you should get after converting it to partial fraction. So before doing anything, you factorize, make sure the denominator, there's some things you need to do. Just check out the previous video, you will understand. So factorizing this s squared plus 4s plus 3, you have that this will be s plus 3 and s plus 1. So are the two values. Converting this to partial fraction, I'll leave the link to, or the previous videos are already there. You can just check any of them. Solving those questions using Laplace transform. Find the inverse Laplace transform using partial fraction. That's for the previous videos. So in partial fraction, this is what you have. 2/3s plus 1/2 s plus 1 minus 1/6 times s plus 3. So from here now, we can now find the inverse Laplace transform. It's very easy now. So inverse Laplace transform of y of s is equal to y of t, which is equal to inverse Laplace transform from the table I sent in the post section. Inverse Laplace transform of 2/3s is just 2/3 plus inverse Laplace transform of 1/2s plus 1 is 1/2 exponential minus t. And for the last, minus 1/6 times s plus 3, inverse Laplace is 1/6 exponential minus 3t. So this is the solution to this question. Thank you for watching. Don't forget to like and subscribe to this channel for more videos like this.